Good evening, all of you. Welcome back to your channel of Learning Mathematics. It's good to see all of you coming back, turning out in time. So as I mentioned yesterday evening, we are going to start with, but we are going to be solving today exercise 10.4. So the concept video on vector cross product or cross product of vectors is already being uploaded. I hope you've gone through that video. If you still haven't, then definitely that video contains all the concepts regarding vector cross product, at least up to 12th standard. So you can just, after this video, you can just go through those videos also. There are many important points which are given. As I've always said before, the NCERT textbooks definitely are not enough for you to practice or really learn mathematics. So as you can see in this exercise also, we don't have many problems which will really give us good practice on vector cross product of vectors. All right, so definitely you are going to need some more reference textbooks. Okay, some more reference textbooks which you will need to practice. All right, so but anyway, since we are following for the board exams, we are following NCERT textbook. So yeah, we will solve the exercise. There are not many questions here today, so I am sure that today we'll finish up a little bit early today. So in the meantime, as we just wait for a couple of more minutes, of course all the videos are already given to you in the concept video there, but yeah, just some reminders which we are going to be needing in this class today. For NBSE, Nagaland Board of School Education, since the marking system has changed since last year, the pattern has changed. So I think this year it's already there in the blueprint. I will try to upload that in the community page. But this year I assume maybe around about 4 marks, I guess, maximum 4 marks from this chapter. But don't look at the marks of this chapter, because as I say, this chapter has a very holds a very important place. Okay, because only if you learn this chapter, then you are going to learn the next chapter, that is three-dimensional geometry, which is of course going to be a very good chapter for, especially in terms of marks, at least 10 marks, I suppose. Yeah, at least 10 marks minimum. And even in physics, especially vector cross product will be very important. So you can just, that's why you can just go through the concept video, because here we're going to be talking about mathematics, not physics. So we are not going to be generally talking about the direction, outcome. No, we are not going to be discussing about that. All right. So as the formula goes, cross product of two vectors is a b sine theta into n cap, where n cap is a unit vector which will be mutually perpendicular to vector a and vector b. All right. In detail, as I say, please go through the concept video and then only you come back again and do this exercise. That will be very helpful for you. A unit vector n cap perpendicular to each one of a and b is given by this. And if you still remember the orthonormal triad of vectors was for dot product I dot I, j dot j, and k dot k was how much? 1. But for cross product, the cross product of like vectors would be always 0. Instead, I cross j will be k. All right, because as we see, you go for the cross product of two vectors, resultant will be a vector, and that resultant vector will be in a direction perpendicular to the other two vectors. So for example, like suppose there are two vectors like this. Now suppose if there are two vectors like this. So if you go for the cross product of these two vectors, then the result will be this one, the scale. All right, the result will be this scale. The resultant vector will be in this direction, either towards you or towards the board. That depends on whether you will go clockwise or anti-clockwise. Alright, so that's why I cross j would be k cap, the unit vector k. Likewise, of course, we do follow the anti-clockwise system. If you still remember, that is I, j, k. I've already discussed about this again in that concept video, so that's why I always say that is very important. Okay. Similarly, so I'm not going to write down all because it's already given to you. So I cross j will be k, I cross j will be k, j cross k would be I, k cross I would be j. But if you go reverse, then j cross I, if you go for reverse, it would be, the direction would change, that is inwards and outwards, it would be minus k. Alright, so these are some concepts on vector cross product. So I guess now we can start with the solution of the exercise, because this video is basically about solution of exercise 10.4. So let's pick up your pen, book, paper, and yeah, I officially welcome each and every one of you back to your place where you learn mathematics. So let's get everything ready. Sit on your table, take out your book, pen, paper, textbook, glass of water, very important, and let's begin exercise 10.4. Yesterday we hit the century mark in the number of likes. Let's see today what we can also do today also. Yes, so yesterday it was a really good turnout, so it was really motivational for me also. Let's see today also. Chalo, let's try to hit that mark. But as I said, more importantly, please, my dear children, try to hit that half century mark during your exams, okay, without fail. Okay, I hope you will do that, so that all our hard work will be paid off. Okay, so please see to it, try at least to hit the half century mark during your exams. That is more important. All right, exercise 10.4. Question number 1. I'm not going to write down the question because I'm sure you have your textbooks, everything with you ready. Question number 1, that is, the two vectors are already given to you. Find the magnitude of the cross product of A cross B. Alright, so let's first find out the resultant vector which we will have from the two vectors A cross B. Let me just write down the vector also. We have recently finished the determinants, matrices and determinants. So I hope you still remember the process of calculating or evaluating determinants. So there are two methods, okay, there are generally two methods with which we can calculate the vector cross product. Alright, there are generally two methods with which we can calculate the vector cross product, but we are just going to stick to one method, that is a determinant way of calculating. Alright, so that there is no confusion when we shift to determinants, when we again shift back to vector, the cross product, there will not be any confusion, we will be sticking to one. Alright, okay. Alright, so this is how we will begin. Alright. Okay, so today we have a dislike, so that's good. Because only if we have dislikers, then we will definitely perform much better, isn't it? Chalo. Alright, so what we will do is when you go for the cross product of two vectors, we'll go for I, J and K. Write down these three unit vectors first. And then write down the coefficients of A first and then B. So the coefficients of A for I, J and K are 1, minus 7, plus 7. And B would be 3, minus 2, 2. Alright, and then as I say, we will be following the concept of determinants. So if you remember determinants, if you go expand along R1, what do? I ignore its row and column, you remember that, isn't it? Same process we are going to be following. So like this. I'll just continue here, that would be. But always prepare yourself, as I have always told you also, like be very systematic, then and avoid all the careless mistakes, then definitely it's going to be very easy for you to score the marks also. So after that, I, j and k, so minus, I hope you know, isn't that why we write this minus? Same concept of determinants. All right, so some textbooks, it will be plus, but the path of multiplication will be just the reverse. So don't worry about that. If both are correct, all right, you just stick to this, no problem. Trust me, no problem at all. You just stick to this. All right. That's why, as I was saying, so that there will not be any confusion when you go to determinants and when you come back to vector cross product also. All right. After that, what do? Same process of determinants. 7 2s are minus 14 minus 7 2s are 14 minus plus. Similarly for this one, 2 1s are 2 minus 7 3s are 21, and this value k, 2 1s are minus 2 minus 7 3s are 21 minus 21 minus plus 21. My dear children, please do try to remember, okay, because whatever we teachers are doing, we are doing all for your benefit only. Sometimes we take the hard way, like sometimes we go and scold you, but that's all with a good heart only, okay, because we want your activeness, we want you to be involved in the study process, because students, we are teachers, you are students, so learning and sharing of knowledge, that is what we are supposed to do. So sometimes we can understand you as children, like you tend to be lost sometimes, so that's when sometimes we have to take the hard way out, and then just to bring you back, so that we can somehow at least secure your future. We do not know about the future, we cannot guarantee what will happen in the future, but at least we will not be guilty that okay, I did not try. So sometimes we have to take the hard way also, just to get your attention, just to bring you back. But at the end of the day, it's all with a good heart. We are just trying to tell you, please, that's what I'm trying to tell you also. Please study, focus on your studies, because education has become so important, and especially with this pandemic, education has become so important. This is the because one thing, I cannot guarantee what will happen to you in the future, but one thing I can guarantee is if you have the right education, definitely you are not going to die hungry. Okay, definitely you will not be left hungry. Absolutely not. That I can guarantee. You will find a way to survive, and that's what I am actually trying to tell you. So sometimes I may be slightly strict. I might be just sometimes we have to take the hard way out. We have to find the harder way. So, but as I say, all in all, ultimate bottom line is I'm just trying to tell you, my dear children, come back. Let's study. Let's help each other out, study. That's the bottom line. So that's what I wanted to tell you also. Okay. All right. So the cross product of A cross B is already calculated. Now let's go for its magnitude. So magnitude will be same. Magnitude will be same just like for dot product that we have calculated yesterday. So now when you go for the magnitude, it's simply square root of the sum of the squares of the coefficients. So that's like 19 square plus 19 square. So that will be 2 into 19 square. So that's going to be 19 root over of 2. Bas. Good evening, all of you. Good evening. Okay. All right. Done. Chalo. Let's go to the next question. So cross product, remember, it's not difficult at all. Same like determinants, the way we multiply. So just stick to this process. There won't be any confusion. Okay. Next, number 2. The formula that I gave you this today. Find a unit vector perpendicular to each of the vectors a plus b and a minus b. So a plus b will give you a different vector. A minus b also will give you another vector. You have to find out a unit vector perpendicular to each of the vectors a plus b and a minus b, where a and b are already given. If you remember, the formula that I gave you was to find out a unit vector perpendicular to each one of a and b was plus or minus a cross b divided by the magnitude of a cross b. Plus minus means either the resultant will be either outside or inwards. So, but of course here, of course vector A is given, vector B is given. That is 3i plus 2j plus 2k, I plus 2j minus 2k. But here, as per the question, we are not supposed to find out a unit vector that is perpendicular to each one of the vectors A and B. We are supposed to find out a unit vector that is perpendicular to each one of A plus B and what? A minus B. So let's first find out A plus B and A minus B. After that, I'll tell you how to do. So I'm just going to add directly. So 3 plus 1, 4. 2 plus 2, 4. 2 minus 2, done, 0. A minus B, 3 minus 1, 2, 2, 0, because 2 minus 2, 0. 2 minus minus plus 2, that's going to be 4. I guess you can catch up, isn't it? Simple addition, subtraction only. So now we are supposed to find out a unit vector that is perpendicular to each one of this and this. So if we just assume this to be vector C, and if we just assume this to be vector D. If you don't want to assume also, you can write it as it is, but if you just want to assume for simplification, then you can assume to be it to be as vector C and vector D. Mom, good evening. So in that case, you can just write down the unit vector perpendicular to each one of A plus B and A minus B is, you can just write directly also, no problem, no need to write. Yeah, chalo, forget it. Equal to plus or minus, as it is given there, A cross B. But what are the two vectors? This one, that is A plus B, this vector cross the other vector. Now, because A and B are A plus B and A minus B. I hope you get the point here. Divided by the magnitude of A plus B cross A minus B. Now compared to dot product, you have to be slightly careful with the cross product. Okay, there are some complications there, so you have to be slightly careful with the cross product. So before we really proceed to that, let's first calculate the cross product of these two vectors. So let's revise once again how to calculate the cross product. So let's calculate. That is, this vector cross product with the other vector would be, as usual, write down I, j, k, and write down the coefficients of this vector first. What is this vector? 4, 4. 4, 4, no k cap. Then A minus B is 2, 0, 4. Okay? I think we will not need this now. So let's get this vector, that is again write down I minus, always prepare like this. I used to do it like that so that I can avoid mistakes. So include 4 4s are 16 minus 0. This one again, if you remove 4 4s are 16 minus 0. This one 4 zeros are 0 minus 4 2s are 8. So that is 16i minus 16j minus 8k. Okay, let's find out its magnitude. So then the magnitude, okay, we'll just do it here. It's not directly. Magnitude we can calculate directly also, right? Or should we? Shouldn't we? Chalo, magnitude also. A cross B, I mean A plus B cross A minus B. Its magnitude will be same, that is 16 square plus, okay, let me just write, minus 16 square plus minus 8 square. So that's going to be 256, 64. How much will this be? 10, 16, 1 left 5, 10, 16, 17, 1 left 2, 4, 5. 576, that is 24. Okay, so done. All right, I'll write here. This is finished. So therefore, you can just write down. Therefore, the unit vector. Since we have already explained, we can just write in short. The unit vector is plus or minus. What was this vector? This one. 16i minus 16j minus 8k divided by magnitude 24. Okay. Let's simplify this a little bit. That's equal to plus or minus 16 by 24i minus 16 by 24j minus 8 by 24k. So that would be plus or minus 2 by 3i minus 2 by 3j minus 1 by 3k. So the unit vectors are, we go for plus, so 2 by 3i minus 2 by 3j minus 1 by 3k, or if you go for minus 2 by 3i minus into minus plus 2 by 3j minus into minus plus 1 by 3k. You can also write like this also. In the textbook it's slightly given in a different format, only the format is different, answer is same only. So you can just write like that also, no problem. Okay. Alright, let's move to question number 3. What is 3? If a unit vector A, unit vector, makes angles pi by 3 with just an example, okay, just an example, that is like something like this, just an example. So like there is a unit vector, okay, unit vector is making an angle of for pi by 3. Actually it's like this, okay, pi by 3 with I cap means x-axis, pi by 4 with j cap represents y-axis. So maybe something like this. It's a 3-dimensional figure, so we really cannot be perfect in the way we draw the figures, okay. So this is pi by 4, and with the z-axis we have to find out another acute angle with the k cap, so that is like z-axis. Then find theta, that is we have to find out how much angle the unit vector is making with the z-axis or k cap. Also find the components of vector A. You remember what is A? A is already given that this is a unit vector. So if you still remember yesterday's class, direction cosines, how to find out the direction cosines? Direction cosines can be simply found out if we just convert a vector into its unit vector, and we can directly get the direction cosines. I gave it to you yesterday, isn't it? Now with the help of that, there is one more concept about direction cosines, which is also introduced to you in the concept video of cross product of vectors. That is, you can note down. Anyway, you can just note down, no problem. You can just write down. Suppose a vector makes an angle, right on. Suppose, good evening, Cynthia. Suppose a vector makes angles, let's say angles alpha, beta, gamma. Okay, alpha, beta, and gamma with the unit vectors I cap, j cap, k cap, respectively. Then we can use the very helpful, okay, then we can use the relation cos square alpha plus cos square beta plus cos square gamma is equal to 1. Remember in the concept video, those who watch the concept video, I've given you L square plus M square plus N square, because L, M, N also represents direction cosines only. Same thing. Good evening, Tamsa. So we're going to use this relation. Alright? We will be using this relation. So as per the question, what do we have? As per the question, if a unit vector A makes angles pi by 3 with I, so maybe let me rub it off. Let's put this as equation 1. So we can just assume that directly we'll just assume that alpha equal to pi by 3, beta equal to how much is given? Pi by 4, and gamma is equal to theta, which we are supposed to find out. So let's calculate. So using 1, in the exams write down this also, okay, it's going to be important. Using 1, we will have cos square pi by 3 plus cos square pi by 4 plus cos square theta equal to 1. So that's going to be cos square, okay, pi by 3, cos 60, 1 by 2 whole square plus cos 45, 1 by root 2 whole square plus cos square theta is equal to 1. So that's going to be 1 by 4 plus 1 by 2 plus cos square theta equal to 1. So cos square theta equal to 1 minus 1 by 4 minus 1 by 2. 4 minus 1 minus 2. 4 minus 3 by 4. 1 by 4. So cos square theta is 1 by 4. So cos square theta is 1 by 4, so that means cos theta will be plus or minus 1 by 2. But theta is an acute angle. That's what is given in the question, isn't it? Always read your questions properly. So in that case, cos theta will be 1 by 2, because cos theta equal to minus 1 by 2 will happen for an obtuse angle only, not an acute angle. So cos theta is 1 by 2. So in that case, theta will be what? Cos inverse 1 by 2. So that is cos inverse cos 1 by 2, cos 60, that is pi by 3. So therefore theta is pi by 3, 60 degrees. So definitely it's an acute angle, isn't it? Okay. So it is an acute angle. So theta we have already calculated. So remember, A is a unit vector. So yesterday you have seen the relation of unit vector and direction cosines. So unit vector and direction cosines, the components will give us the direction cosines. So that means, so the components of vector A, or let's say A cap because it's a unit vector, are cos pi by 3, first angle, second angle cos pi by 4, and the other, this one, cos pi by 3. Because yesterday you remember, no, how we calculated the direction cosines directly from a given vector, convert that to unit vector, the components of I, j and k, coefficients of I, j and k directly gives us the direction cosines. I hope you remember yesterday's class, right? So we are just applying that reversally now. So cos 60, 1 by 2, cos 45, 1 by root 2, and this one also 1 by 2. So these are the components of vector A, which is, okay, sorry, components of, let's say, vector A, let it be, because it's a unit vector, so hold on, no problem. Mugiri, good evening. Today, slightly late. Because you are also very regular. Alright, let's move on to the next question, ladies and gentlemen, boys and girls. Okay, what do we have with the next question? Number 4. Show that A minus B, simple question, cross, yesterday we did it for dot product, is equal to 2 times of A cross B. So cross product, definitely there is a lot of change. Let's see if we just multiply. So A minus B cross A plus B would be multiply. A cross A plus A cross B minus, careful here, you just cannot change, B cross B. Now, in the beginning of the classes, I have already given to you that when you go for the dot product of like vectors, it is 1. But when you go for the dot cross product of like vectors, it is 0. Like vectors, A, like to na. So, A cross A, 0, plus A cross B, and this one from vector cross product, we have also seen in the concept video that A cross B will be minus of B cross A, because this changes the direction, because our resultant is a vector, so here we have to be really careful with the direction. For dot product, actually it doesn't matter, because dot product of two vectors results in what? Not a vector, it results in a scalar. So a scalar doesn't have any direction, so we are not concerned. But vector cross product will give us a vector. So if we just replace this minus b by a is nothing plus a cross b. Just change the direction. This is 0. So now you see a cross b, oh yeah, 2 times of a cross b. So this is just about knowing your concepts correctly. If you know your concepts correctly, you can get the proof or the solution done. Very easy. Okay. Alright, so today also we're at the half-hour mark. So time to get some glass of water. Get a glass of water. Chalo, you can prepare yourself for the next question, or you can have a glass of water. Alright, number 5. Find lambda if the cross product of these two vectors, 2i plus 6j plus 7k. 27. 27, isn't it? Yeah. I plus lambda j plus mu times of k is a 0 vector. So what is the cross product? As we know, I, j, k. 2, 6, 27, 1 lambda mu. 0 vector. So if you just go for the cross product, 6 mu minus 27 lambda I minus 2 mu minus 27 j cap plus 2 lambda minus 6 k cap is equal to 0 vector means 0 I, 0 j, 0 k. Just for comparison, no? To compare the coefficients. Alright, so we can't do anything now. Now we can write on comparing the components of I cap, j cap, k cap. 6 mu minus 27 lambda equal to 0. So our job is to find lambda and mu only. So let's take the two equations. So minus 2 mu minus 27 equal to 0. So minus 2 mu equal to 27. So mu equal to minus 27 by 2. sorry, this is minus, what am I doing here? So minus 2 mu plus 27 equal to 0, so minus 2 mu equal to minus 27, so mu equal to 27 by 2, no problem, and 2 lambda minus 6 is equal to 0, 2 lambda equal to 6, so lambda equal to 3. You can verify your results. Good thing, this is how we verify, especially in this kind of cases, 2 and lambda equal to 3 in 6 mu minus 27 lambda equal to 0. See what we get. Is it verified or not? So 6 into 27 by 2 minus 27 into 3. 2, 3. So 3 into 27, 381 minus 81 equal to 0, 0 equal to 0. That is true. No? 3721, 2 left, 6 is, yeah. So that way also we can verify just to confirm our results during the exams. Okay? Alright, number 6. Another conceptual question there. 6. It says given a dot b is equal to 0 and a cross b is equal to 0. What can you conclude about the vectors a and b? What can you conclude about the vectors a and b? Okay, from the first one, a dot, yesterday we have already seen about this one slightly, isn't it? So if a dot b is 0, then either the magnitude of a equal to 0 or the magnitude of b equal to 0, or what? Or vector a is perpendicular to vector b. Because yesterday we have seen orthogonal vectors, isn't it? How do we prove that the two vectors are orthogonal if the dot product of the two vectors is 0? So if the dot product of two vectors is 0, then we can either say that a equal to 0 or magnitude of vector b equal to 0, or the two vectors are perpendicular. Okay. What can we say if the cross product is also 0? Same case, that is either a is 0 or b is 0, or you remember a cross b was just talking of the magnitude, b, if you just talk of the magnitude, sine theta, it was given by sine theta. So when will you get this as 0? If a or b both are 0, either one are 0, or if both are not 0, if they are non-zero, then what should be the angle so that the value becomes 0? Sine 0 is 0, isn't it? Then in that case, like theta is 0 degrees, so vector a in that case is parallel to vector b. That's one condition. This is also done, okay? This is also done before. So that means for dot product, if it is 0, perpendicular. For cross product, if it is 0, parallel. Now have a look at this. This is what is given in the question, and then they are asking us, with these two results, what can you conclude about the vectors a and b? Now you see, we have two results here. Either this or this, but you know, two vectors simultaneously cannot be perpendicular to each other as well as parallel to each other. That's practically not possible, isn't it? Vector a and vector b cannot be simultaneously perpendicular or parallel to each other. So the only conclusion that is left for us is, so either vector a is a 0 vector or vector b is a 0 vector. This is the only conclusion that we can derive from the given informations in the question. Okay? Chalo. Done now? Alright, then let's go to number 7. Alright, chalo. Number 7. Let the vectors A, B and C be given as, it's already given. Chalo. Anyway, I'll just write A1I, A2J, A3K. Vector B, B1I, B2J, B3K. Vector C, C1I, C2J, C3K. Alright, that's what is given to us. Show that A cross of B plus C is equal to A cross B plus A cross C. We have to verify that, isn't it? No problem, we will do that. How do we do that? Let's directly start calculating. That is, let's just calculate the left hand side first and see what we will have. That is A cross B plus C. Let's calculate this. Anyway, I'll just do. What will be B plus C? B plus C. Like vectors you add, so that's going to be like B1 plus C1. I cap. B2, of course you can do this directly also. B3 plus C3 K cap. You can of course do that. Just for reference if you need, nah? So what will be A cross B plus C? So if you go for A cross B plus C, we will be having I, J and K. A, that is A1, A2, A3. And what is B plus C? This vector is this one. So only the components B1 plus C1, B2 plus C2, B3 plus C3. Alright, now this is what we have. Now here maybe we can use a little application of determinants. I'll just write it. You remember determinants, if a particular row or column is a sum of two elements, we can separate them as different determinants. You remember that particular property of determinants? We are going to use that here. That is, this determinant only, this one also valuable. It can be written as a sum of two determinants, I, J, K. I, J, K. So we can write this as A1, A2, A3, same. A1, A2, A3. This one I can write as B1 plus C1, B2 plus C2, B3 plus C3. Alright, that's the least that we can do as of now. Remember using properties of determinants. Of course, if you think you will confuse, you can here in bracket, you can just write write down, using properties of determinants. Using properties of determinants. Okay? Alright, now let's go to the other part. Technically speaking, definitely there is a lot of difference between perpendicular, altitude and height, but in a layman's language they are actually all the same. But technically if we speak, then for different topics they have slightly different meaning. Is same, but we use it differently, like different languages and all. So like in trigonometry we generally prefer opposite side, not altitude or height. But for a right angle triangle, Pythagoras theorem, okay, altitude, perpendicular, height, actually they're all the same. Okay, yeah, not the same only. Quite a question there. So perpendicular, height, because height is always perpendicular and altitude is always height only. So there's technically, it might differ, but yeah, it's same only. Nothing much difference. Only in trigonometry, instead of perpendicular height, we use opposite side. No? Opposite side. We don't use perpendicular height or altitude. Generally, in trigonometry, we prefer opposite side. But yeah, they have the same meaning. Perpendicular, altitude, and height. Yeah, they have the same meaning. They are same. Now, if you go for A cross B, I, J, K. Plus B cross C, I, J, K. Now A cross B, so components of A1, A2, A3, components of B, B1, B2, B3, B cross C, components of B, components of C. Now there is nothing to do there. See, same, isn't it? Bus. So the trick was actually on the left hand side. Okay, so the trick was actually with the left hand side. Perpendicular, height, altitude, they have the same meaning. We just use it differently in different fields, that's all. Okay, but it's same, they're all same. They have the same meaning only, but yeah, we use this three letters differently in different formats, but that's all. But meaning is same. Idea is same, concept is same. Which when you go for height, it's perpendicular only. Altitude is again perpendicular only. Perpendicular altitude. Altitude means height from the ground. Slight variation can be there technically, no? Eight. If either vector A is a zero vector or vector B is a zero vector, then A cross B is zero. No problem. Sure. Because if either one of A or B is a zero vector, then definitely one entire row or column, entire row will be zero, so cross product definitely will be zero. No problem with that. But the question is the converse true? That means question is something like this: if A cross B is zero vector, then is it necessary that A is zero vector or vector or B is a zero vector? That is what the question is actually. If you couldn't understand, that's what the question means actually. Okay, now this part there is no doubt about that, because if A is a zero vector, B is a zero vector, either one, though definitely the cross product of course will be zero. No problem with that. Now what they are asking is, on the other hand, if A cross B is a zero vector, is it necessary that either one of the vectors has to be zero? Answer is actually no. Answer is actually no. Similar question was done in yesterday's exercise 10.3 also. Answer is actually should be no. Because without both the vectors being zero also, their cross product can be zero. How? You remember, if two vectors are parallel to each other, then the cross product will also be zero, because the angle made between them, theta, will be what? 0 degree. And we know that sine 0 degree is what? 0. So in that case, the cross product of two vectors definitely is going to be 0. So it's not compulsory and necessary that the two vectors has to be zero vectors. They can be non-zero vectors also. So answer is no. Okay, answer is like no, because you can write down in your own words, okay, because there are many approaches to this. You can try in different approach also, because if A cross B is a zero vector, then like A cross B is like A, B, sine theta is a zero vector, I mean 0, so that means sine theta is 0. So that means theta is equal to 0 degree. So that means A is parallel to B. So the only condition is that they can be parallel. Alright, so it's not compulsory that they have to be zero vectors. Example. For example, like if vector A is I cap, vector B is I cap, then what will be A cross B? That is I cross I. And that would be I sine 0 degree, because I both are representatives of the x-axis, unit vectors of the x-axis. So the angle between them is 0. So this value would definitely turn out to be what? 0. So it is not, so the converse need not be true. So the converse need not be true. Okay? Alright, got it? No? Yeah, think about it. Okay? You can do it in a different way also. You can take some other examples also, not only I and I. You can take similar examples like parallel vectors. You can take any two parallel vectors also. You can take. Alright, number 9. Find the area of the triangle where vertices are this, and this. As I've told you yesterday, whenever vertices are given, position vector of A, OA vector, position vector of B. Always remember that first get the position vectors, otherwise you're going to make a very silly mistake. Position vector of C. So with respect to the I plus J plus 2K, 2I plus 3J plus 5K, I plus 5J plus 5K. Always go for the position vectors first. After that, we will discuss what we need to find out. Now, again, this also I had already given to you, that is, area of triangle ABC would be half of the magnitude of AB cross. What was it? AB cross. You can check your formulas quickly if you have noted down. If you have written it down, it should be what? AB cross AC. Yes, exactly. So our job is to find AB. So that's going to be what? OB minus OA. And AC, OC vector minus OA vector. Let's try to calculate this. OB minus OA. 2 minus 1. 1. 3 minus 1. 2. 5 minus 2. 3. OC minus OA. 1 minus 1. 0. 5 minus 1. 4J. 5 minus 2. 3K. So this is done. Let's get the cross product, magnitude, area. Very simple. So, first get the cross product. AB cross AC. IJK. 1, 2, 3. No I cap here. 0, 4, 3. So that will be 2 3s are 6 minus 4 3s are 12I minus 4J, 3 1s are 3 minus 0J plus 4K, 4 1s are 4 minus 0K cap. This one ho gaya? Rubbing it off, okay? 5 4 3 2 1. Okay, this one I'm just going to calculate here so that I'll use the formula directly. Okay, na? Okay, na? Solo. Okay, so this one will be minus 6I minus 3J plus 4K. Okay? Alright, if you haven't, whether you've observed or not, we need just one more like to get that half century, 49 already there. So he's going to give me that one like extra like 50 century, half century, not 50 century, half century, just one like there, it's already 49. Who's going to give it? Yeah, who did that? Please comment. Who gave me that half century, the last one run, just to be 50, number 50, who was it? Number 50, come on, I need to know, number 50, who was it? Number 50, who was it? Come on, let me know in the comment section below. Number 50. Who was it? Come on, who is going to be the one? Okay, so a big round of applause for each other. Alright, chalo, today also we have got 50. Wow. All right, thank you so much again, once again, all of you. Not only him alone, but like, thank you so much again, once again, like for your cooperative, and it feels good that you understand what I'm trying to do here for all of you. So it does feel good. Okay, you don't mind also, and then it's really motivating for me. I say that every class because I really mean it. Okay, it's really motivating for me, especially those who are consistently cooperating with us. So I really mean it straight from the heart. I really mean it. What do we call it? Sarangi or something like that. Again. Alright, so let's continue again. So area of triangle ABC equal to this. So that's going to be 1 by 2 into magnitude of the vector 6i minus 3j plus 4k. So that's going to be 1 by 2 square root of minus 6 square plus minus 3 square plus 4 square. Yeah, half century. Chalo, we are hitting half century mark almost every day. That's all because of your support only. Without you, not possible, na? So it's all because of your cooperation only, not because of me. Absolutely not. 36 plus 9 plus 16. So that's root over of 6, 6, 12, 21, 2, 9, 10, 11, 12, 13, 14. 141 1. Nah, how come? What did I do just there? Okay, maybe I was just too happy hitting the half century. Alright, 16, 16, 36 plus 16, 36, 46, 47, 48, 49, 50, 51, 52, 52 plus 9, 61. So 61 by root 2 square units. So that's the area of the triangle. Simple questions. Alright then, chalo, let's go to number 10. Then again, what is the question there? Find the area of the parallelogram whose adjacent sides are given. So yeah, this one also you will have the formula, but I'll just give you, that is the area of the parallelogram with vector A and vector B as its adjacent sides is given by magnitude of a double of the area of triangle, because we know the relationship between parallelogram and the triangle, no? Especially with the diagonal in terms of area. So yeah, we'll have to first find out A cross B. Cross product I, J, K. So it's 1 minus 1, 3, 2 minus 7, 1. So that's going to be minus 1 minus 7 3s are 21 I minus for J 1 1s are 1 minus 2 3s are 6 plus K minus 7 minus minus plus 2 K. I hope you can see, right? Okay, so that's going to be 20I minus 5J minus plus 5J minus 7 plus 2 minus 5K. So A cross B, we have that. I plus 5J minus 5K. So let's find out the area of the parallelogram then. Therefore, area of the parallelogram is magnitude of A cross B. So what is A cross B? Its magnitude, that's 20 square plus 5 square plus minus 5 square. So how much will that be? 20 square, 400 plus 25 plus 25. So that's 450. So 450 to 25 into 2, isn't it? 450 to 5. 225 is 15, right? Not mistaken. 515, yeah. So that will be 15 root over of 2 square units. Almost done. So that's the area of the parallelogram. Okay, now? Alright. Got it? Chalo. Okay, what is the next question? 11. Okay, this is a multiple choice question. So only 2 more questions left. Chalo, let's do it. Let the vectors A and B be such that the magnitude of the vector A is 3. Magnitude of the vector B is root 2 by 3. And it's given that A cross B is a unit vector if the angle between A and B is what? A cross B is a unit vector. A cross B is a unit vector write down A cross B is a unit vector if the magnitude of A cross B is 1. So the magnitude of A cross B is magnitude of A dot B, A cross B into sine theta equal to 1. Did you get this? Because you see, cross product, we actually ignored that part, but see, the cross product is actually A cross B. The cross product of A cross B is A, B. Remember cross product, sine theta, today I gave you, into n cap, which is a unit vector. This is actually the cross product. Alright, now if you go for the magnitude of this cross product, magnitude of this cross product, the other side, okay, the other way around, then magnitude of A will be magnitude of A, magnitude of B will be magnitude of B, sine theta, this is will remain as sine theta, then magnitude of n cap, so n cap is what? A unit vector, so this value of course will be 1, so that's how we get this relation. You got the point? Because no, some of you must be wondering like, magnitude, how do you just write like that? Because of this concept only. Because A cross B is this. You go for its magnitude, because A cross B is A, B, sine theta into n cap. Because remember, cross product will give us a vector quantity. Vector quantity, which is n cap, which is perpendicular to each one of A and B. So when you go for its magnitude, magnitude of A remains A, magnitude of B remains magnitude of B, sine theta remains same, n cap, magnitude of n cap is 1. So that's how we only have this value, it's all the same. Which, go here, which, so now A is 3. I'll just write into, this is not cross product again, okay, this is like into root 2 by 3. Okay, if you think you will confuse something like this, you can just write down sine theta equal to 1. So sine theta will be equal to 3 cancels 1 by root over of 2. So sine theta equal to what? Sine pi by 4. So as for the options that we have theta as pi by 4. So as for the given options, we will be having theta as pi by 4, number B. Alright, the last one. The final question of the day. Area of a rectangle having vertices A, B and C with position vectors already given. So let's just say this is a rectangle. A, B, C, D. So with respect to the axis, it's like OA, OB, OC, OD. Of course, 3-dimensional, but anyway, we'll just, this is what it means, respectively is. So how do we find out the area of a rectangle? See, area of A rectangle is also a special case of a parallelogram only, isn't it? Parallelogram also opposite sides are equal. Just that in rectangle, the angle between any two adjacent sides is how much? 90 degree. That's the only difference. So we can just use the same formula for a parallelogram also. Okay, just considering it as a special case of a rectangle. So we'll have to go for the area of rectangle. Area of rectangle would be product of any two adjacent sides. So that is, if you go for AB, it should be AB cross AD. Alright, AB cross AD. Got it? Okay, so considering it as a special case of a parallelogram. So let's calculate that quickly. Okay, 100k likes, so I don't know. Maybe very soon, I guess. Hard work and consistency always pays, and definitely I am sure we'll hit that 100k like, not 100k likes, sorry, 100 likes. 100 likes. Now let's talk of small things only. 100 likes with your support. Your support, definitely I'm reaching that, isn't it? Am I right? I hope you will be there with me always like this. I'm very sure of it. So for that, we will have to first find out AB vector, that is position vector of B minus position vector of A, and AD vector, that is position vector of B minus position vector of A. So that would be position vector of B is the second, that is I plus 1 by 2j plus 4k minus position vector of A, first vector, minus I plus 1 by 2j plus 4k, and this one OD minus OA D vector minus I minus 1 by 2j plus 4k minus A vector minus I plus 1 by 2j plus 4k. So this is how you will be finding out the vectors AB and AD. Thank you, Kinkali, for those sweet words. We'll share as much as we can to reach that. Definitely, I'm sure, because as I've always said, again I'm going to say, and I'm going to continue saying that, because like I'm really actually very honestly touched by the motivation, because many of you really understand that what I'm really trying to do for you here. So it's really motivational for me. It's really a source of encouragement for me, because many of you understand that I'm trying to, you know, get close to you and help you, and then learn in the process. So definitely, yes, let's keep our hopes high, and then yes, please do share so that we can also increase our subscribers also, because there are two reasons for that. One reason is we have to reach out to as many students as we can, because all over the state, all over the country, definitely there will be many who still do not have any idea about this. Second reason is knowledge is all about sharing. So as much as we share, definitely we will learn also again. As I've said, I've never said that I'm perfect. Absolutely not. So the more we try to teach, the more we learn. So it's not that only you are learning, okay? It's not that only you are learning. I'm also learning. It's an everyday process. I'm also learning here. So it's not that, don't you think that only you are learning. I am also learning here, okay? I am also learning here. You have already seen, those who have been consistently with us, you've already seen, I have done many wonderful things. I have done very unique things which I've never thought I would do. Remember that? All right, right, you remember, no? Right. So as I say, these are all learning curves for us. All right. So this is how you'll find out AB, and you will find AD, get the cross product, get the magnitude. I think you will be able to do that. So please complete this question. I'll leave it to you here, and do let me know in the comment section below if you have any problems. I'm sure you will be able to solve this. Alright, so you can take your time, and you can try at home, and then please let me know if you're not able to do that. Alright, right then, my dear children, my beloved students, that's it for today. So just one more exercise left on these vectors. See, when we really have the determination, a lot of things can be achieved. So even though all of us we were tired, all of us we're exhausted, we still finished it. Just one more exercise left for us to finish up these vectors. So please go through it again and again, and definitely this exercise we will try to finish it up tomorrow, the scalar triple product. All right, so that's it, my dear children, for today. Thank you so much, each and every one of you, for being a part of this. And yes, I'll see you tomorrow. Please stay safe and study well. Okay, all right then, take care. Bye bye.